Plasma proteins. Plasma proteins include albumin, globulin, fibrinogen, and prothrombin. The total amount of plasma protein in the blood is 6.4 to 8.3 gram per cent, and the normal albumin globulin ratio is 1.7 is to 1, and this ratio is reversed in case of liver disorders as the albumin synthesis is decreased in liver disease. Plasmapheresis or Whipple's experiment is an experimental procedure done in animals to demonstrate the importance of plasma proteins. Some of the functions of plasma proteins. It is involved in the coagulation of the blood due to the presence of fibrinogen, prothrombin, and clotting factors. It takes part in coagulation of the blood. It is involved in the defense mechanism of the body as gamma globulins. They're going to produce antibodies. They maintain colloidal osmotic pressure. Almost 80% of the colloidal osmotic pressure is due to the albumin, and colloidal osmotic pressure is inversely proportional to the molecular size and directly related to the concentration of the molecule. It is involved in the transport. Albumin and globulin transports various hormones, enzymes, bilirubin, and metals like copper, iron, etc. Plasma proteins are very important for acid-base balance or regulation because of their buffering action. It provides stability to the blood. This is due to the presence of globulin and fibrinogen. If the blood loses viscosity, RBC will pile upon each other and leads to Rayleigh formation. Plasma proteins are important for maintenance of systemic arterial blood pressure as the viscosity of the blood is mostly due to the fibrinogen, and arterial blood pressure depends on the viscosity of the blood. And plasma proteins acts as a protein store. So here are some of the differences between albumin, globulin, fibrinogen, and prothrombin. The molecular weight of albumin is around 69,000. The normal plasma level ranges between 3.5 to 5 gram per cent. It is produced in the liver. Some of the important functions are binding and carrier protein. It acts as a binding and carrier protein, and it is important for osmotic regulation. Globulin molecular weight is a bit high. It is between 90,000 to 1.5 lakhs. Its concentration ranges between 2 to 3 gram per cent. It is produced by the reticuloendothelial cells and plasma cells, and it is important for mediation of immunity. And it acts as a transport proteins for as a transferrin, ceruloplasmin, and hemopexin. And fibrinogen, the molecular weight is around 3.5 lakhs, and its plasma level ranges between 0.2 to 0.4 gram per cent. It is produced in the liver, and it is important clotting factor for the clotting of the blood, and it provides the major part of the viscosity to the blood. Where prothrombin, the molecular weight is around 68,000, concentration is 0.1 gram per cent. It is also again produced in the liver. It is important clotting factor in the blood. Hyperproteinemia, increase in the level of plasma proteins, is seen in conditions in which there is a hemoconcentration, for example, diabetes insipidus. Hypoproteinemia, where the decreased levels of plasma protein is observed. It is seen in malnutrition, burns, malabsorption, and hemorrhages. This causes decrease in colloidal osmotic pressure, therefore increase the filtration occurs at the arterial end, and decrease in the absorption at the venous end occurs, and this is going to result in edema. In liver disorders, Ag ratio reverses when the body tissues are damaged. Though plasma albumin falls, the plasma immunoglobulin increases as a result of plasma cell hyperplasia, causing Ag ratio reversal. multiple myeloma where there is increase in the levels of globulins due to the malignant growth of plasma cells.